Today my topic is OSI model. This video is much longer than my other videos, even though I try to simplify it. OSI model is a very useful tool for learning and understanding about network technologies and protocols. It's a great model at explaining how data flows between network hosts and what role of protocols play in the data transmission process. So please bear with me. OSI model has 7 layers, starting from layer 7, application, presentation, session, transport, network, data link, and physical. Here are some tricks to help you to remember these 7 layers. From layer 7 to layer 1, you can use this mnemonic. All people seem to need domino pizza. All people seem to need domino pizza. Or you can use this one. All people should try new Dr. Pepper. All people should try new Dr. Pepper. You can use one of them, whatever works for you. From layer 1 to layer 7, you can try this trick. Please do not throw sausage pizza away. Alright? Please do not throw sausage pizza away. It's kind of all about food and drink. Now let me demonstrate how data flows through each of the 7 layers of the OSI model when the client makes request to the server and then server replies to the client. Data is generated at application layer on the client side, travels down the stack to presentation, session, transport, network, data link, and then physical. Then through the network media, data travels to the physical layer on the server side, then up to data link, network, transport, session, presentation, and application. When the server responds, server data goes down from a top layer, application, to presentation, all the way to the physical layer, and then through the network media, all the way to the client side, and then travels from physical layer, data link layer, all the way to the top layer, application. Thus completing one round trip. The round trip of how data flows through all these 7 layers on both sides is a physical path on which data actually and physically flows. Keep in mind, the OSI model also addresses another important aspect how data flows on a logical path, layer-to-layer communication. For example, the sender's application layer generates data, while the receiver's application layer reads data. The sender's presentation layer encrypts and compresses data, while the receiver's presentation layer decrypts and decompresses data. The sender's transport layer chops up data into segments, while the receiver's transport layer put all these segments together. The sender's network layers make a packet, while the receiver's network layer opens the packet. And the sender's data link layer makes frames, while the receiver's data layer opens frames. Now let me talk about the OSI model layer by layer. Let me start with the layer 7, application. In non-technical terms, application layer is about users' application, such as Firefox, Chrome, or Safari for website, or Microsoft Outlook for email. Technically, this application layer refers to application protocols, such as HTTP for web pages and SMTP, POP3, IMAP4 for email. Those protocols facilitate communications between your application and your operating system. Application data is generated here. Layer 6, presentation layer. The presentation layer provides a variety of coding and conversion functions on application data. These functions ensure that information sent from application layer or client would be understandable and comprehensible by the application layer of the server. To put it simply, this layer is trying to translate application data into a certain format that every different system could understand. For example, if I send a picture to my friend's computer, I must use some standard formats like GIF or PNG so that my friend's computer could understand. If I want to share videos in YouTube, I must use a standard format like MP4 or AVI. Another example, as a professor of University of St. Mary in Leavenworth, Kansas, I must speak English, or at least Chinglish. Otherwise, my students would complain. If I use an irregular shape to represent the application data, presentation layer would change it to a square which everyone is familiar with. Therefore, the main function of this layer's protocols are basically about data conversion, data encryption, and data compression. Layer 5, session layer. The best example to explain this layer is a telephone call in which first you establish the connection, then start a conversation, and then terminate the session. Thus, the major function of this layer is simply establish, manage, and terminate connection between the sender and the receiver. Without this layer, the data would not go any further. Layer 4, transport layer. Transport layer accepts the data from the session layer and chops up the data into smaller segments and add header information such as destination port number, source port number, and a sequence number which is used by the receiver to put the segments back in order and assemble them. The main protocols in this layer are TCP and UDP. In a separate video, I will talk about their difference in detail, but here we only need to know that TCP is a dominant protocol. Once the transport layer completes its job, these segments are moving to layer 3, network. The Internet Protocol, or IP, the primary protocol at network layer, takes the segments and adds actual header information such as sender's IP address and receiver's IP address. Thus, packets are created. Network layer is all about IP addressing and IP routing. Without this layer, packets will never travel to any other networks. Receiver's IP address is like a receiver's mailing address on an envelope. Without it, your letter will never be delivered to the destination. Layer 2, Data Link Layer. When the IP packets arrive at this layer, more header information such as source and destination MAC address is added to each packet. A trailer FCS is also attached to the end of the packet. Altogether, Ethernet frames are created. MAC address is physical address for your network interface card or NIC. At this layer, NIC has a crucial job of creating frames on the sender side and reading or destroying frames on the receiver side. Last but not least layer, physical layer. Protocols at the physical layer accepts frames from the data link layer and generate bits. And these bits are made of electrical impulses or light, depending on whether the copper wires or fiber optic is used. Through the network media, the data travels to the receiver, thus completing a whole journey of 7 layers on the sender side. Keep in mind that OSI model is not a laws of physics. It's only a guideline. Whilst many protocols fit neatly into one of the 7 layers, others do not. But the OSI model is a great tool to learn and understand how network hosts communicate with each other. Any serious network professionals and students should know. I hope this video is helpful, and thank you very much, and see you next time.